All right, for this calculator, we're going to be looking at odds ratio. I've got three different odds ratios here that we're going to be looking at. Imagine that you're at a picnic, a family picnic. Your grandma has made something to bring, your mom's made something, and also your uncle Grey Wolf has made something. I actually do have an Uncle Grey Wolf. That's not his real name, but it's his chosen name. It was. He went off and joined a Renaissance fair and traveled around with him for a while, and that was the name that he went by. So, no one knows why. Anyway, we've got these three different things at this picnic. Everybody was eating and drinking different things, and some people got salmonella. They got very, very, very sick, and we have to figure out whose contribution was the worst here. We think, Grandma's getting kind of old. Again, let's just dig into my history here. My grandma's getting kind of old. When she cooks, things get left out for many hours. And sometimes, because she lives maybe a little bit like a witch in a story, there's like spiders and mice that seem to live at her house. They always have. This isn't just like an old person thing with her. I think leaving the things out is an old person thing, but she lives with a lot of nature inside of her house. So anyway, we've got Grandma's potato salad, and that seems like a likely culprit. A lot of people ate that. A lot of people also ate Mom's fried chicken. My mom does make fried chicken, and it's damn good. And then we've got Uncle Grey Wolf's bathtub rum. My Uncle Grey Wolf does not make bathtub rum, I don't think. I don't know. But he seems like the kind of guy that would. And it'd probably be pretty good bathtub rum if he did make it. He's competent at things. Maybe not choosing names, but at everything else. Pretty good. So we're going to do this odds ratio here, and I'm going to figure out which one looks like the culprit. So we have 4 cells in all of these. And it doesn't matter what you're looking at. It doesn't matter what you're measuring. You're going to have these same 4 cells because we're comparing 2 things, right? We've got Grandma's potato salad. You either ate it or you didn't. And we've got salmonella. You either got it or you didn't. You can think about this like a vaccine, right? Let's think about a coronavirus vaccine. Well, coronavirus vaccine. You either got it or you didn't. And then coronavirus, you either got it or you didn't. And this is one of the ways that we actually determine the real world effectiveness of those vaccines. I mean, yeah, we can do testing in the lab with cells. And in the UK, they're actually starting to get volunteers to actually expose to coronavirus. But most tests don't actually expose people to pathogens like that. Most tests actually just look at who got the vaccine, who didn't, and then who got the illness and who didn't. And that's how we gauge effectiveness. It's not the most... If you're thinking about doing experiments, it's not the most sound way, but also is exposing people to a pathogen the most ethical thing. So you do kind of have to gauge those two. So it doesn't matter what you're looking at. It could be, did you study? Yes or no? Did you pass the exam? Yes or no? So you could do any of these things. You've got these 4 cells no matter what. So what we're going to do is we're going to put our information that we know. We're going to label it right here. This is what's going to go into the calculator, and then we'll do our calculation next. The first thing that we want to put in is why. Yes, yes. Yes, you ate the potato salad. Yes, you got salmonella. The next thing we want to put in is the prior thing the yes for the prior thing and the no for the result. So we want to put in yes potato salad and no salmonella, or yes studying and no I did not pass, or yes I got a vaccine and no I did not get coronavirus. So we're doing what comes first, right? You have to eat the potato salad before you get salmonella. So first comes first. Now we're going to do no, I did not eat potato salad, but yes, I did get salmonella. And the last one we're going to do here is no, no. Okay, so we've got data in all these columns, and now we can actually figure out the odds ratio. Let's go ahead and put numbers in for Grandma's potato salad. So we got 41, we've got 8, we've got 2, we've got 3. And here we're going to make the calculator. Start with an equal sign. Always start with an equal sign, right? And I'm going to do a grouping of parentheses here. So we're going to do open parentheses. What we want to do is we want to divide the yes, we did eat this thing, or yes, we did get this vaccine, or yes, we did study, whatever. We want to combine the yeses. And I say combine, I actually mean we want to divide them. So we want to go A2 divided by B2 and close that parenthesis. So what this is doing is this is giving us the yes, people who ate potato salad and got salmonella over yes, people who ate potato salad and didn't get salmonella. So it's giving us, we're looking at just people who ate potato salad, and we're looking at the proportion of people who got versus people who didn't. So we're dividing people who got it over people who did not. So that's what we have. Then we're going to divide the result of that by another proportion here. And that is going to be the no's. So people who did not eat potato salad, we're going to divide the yes, they got salmonella by the no, they did not get salmonella. So this is just going to be C2 divided by D2. Close your parentheses and hit enter. 7.69. Okay, great. That's excellent. What I'm going to do here is your calculator can end here. I'm going to do something, and I'm going to paste it right here, and I'm going to also come down and I'm going to paste it right here. So I've got the same formula, but since I've copied it from here and pasted it down here, now instead of looking at row 2, it's looking at row 10. So I can put in new numbers here and calculate a new odds ratio. So let's do it for Mom's Chicken. We got 20, then 24, then 5, then 5. And that gives us 0.833. And now we're going to do it for Uncle Grey Wolf's Bathtub Gin. That sounds like something you could totally sell. So 4 and 17 and 22 and 11. And that gives us 0.12. So notice that we have very different odds ratios for all of these. And there is something that we can learn from this. So if I go down here and reveal what I've already set up, this is what our odds ratio is telling us. If it's greater than 1, it implies that there's an association. So Grandma's potato salad seems to be associated with getting salmonella. And that's true in my experience. If you eat something that my grandma's made, you might catch something. It could be a cockroach, but it'll be something. Then if you go down and look at Mom's Chicken, 0.83, this is pretty close to 1. A 1 implies no effect. Basically means the number of people is just kind of randomly distributed throughout. Like who got salmonella is randomly distributed throughout. It makes no difference whether they ate Mom's Chicken or not. could have, they could not have, and they ended up getting salmonella or not kind of randomly. So it's equal. There's no effect of mom's chicken. And then if you look at Uncle Grey Wolf's bathtub gin, you see that it's pretty low here. And a number that's less than 1 implies a protective effect. And in fact, I don't know if this actually works for salmonella. I don't know if rum, I don't know if bathtub rum would protect you from salmonella, but there is good evidence that whiskey would protect you from cholera, which is also a bacteria. It's a waterborne bacteria that causes, I was going to say food poisoning. It's a hell of a lot worse than food poisoning. It causes death in pre-industrial times. Not so much anymore, depending on what country you're in. But it's a pretty gnarly illness. Salmonella is too. It can also cause death, but I'm just not sure if bathtub rum kills salmonella. But assuming that it works the same, a drinkable alcohol kills a foodborne bacteria, consumption-borne bacteria, then you would see a protective effect like this. So again, I'm not telling you that your uncle's bathtub gin is going to protect you from salmonella. All I'm saying is it has happened similarly in the past. And an odds ratio of less than 1 is going to show you a protective effect like that is really what we're talking about here. So here's your odds ratio calculator right here at the top. And, I like to throw border around the thing. These should be green to remind you that these are what you put in. This is user input. And this should be yellow to remind you that this is something you shouldn't touch, because that's where the formula is. So you build this and you go to use it a month later. You'll remember what's something you should put in and what is something you should not put in. Okay, that's it, and I'll see you in the next video.